Yeah, today the topic is angles in real life. Okay, see, first I will just give a rough introduction. What is angle? Actually, this is already discussed in other video. I will just roughly give an introduction like what is angle. First, I will put a point, one point. Starting from this point, draw one line, any one line like this. Starting from the same point, draw another line. Okay, so two lines you have to draw, first line, second line, and their starting point should be same. Okay, now this is the angle. Okay, so the space formed, this one, this is angle. So this is what we call as angle in math. The topic is angles in real life. In real life, where and all we can see angles. Okay, that some real examples I will show. I will show or I will tell. Okay, for example, scissor. To cut the air, we'll use scissor, right? I'll just draw a rough diagram of a scissor. So this is scissor. Uh, to cut the air, if you go to cutting shop, they will use scissor, right? Or to cut the papers, we will use scissor, right? So this is scissor. Just assume I have just drawn the rough diagram. So see, between this and this blade, this is a blade and this is another blade. So whatever is there here, this is angle. The space that's formed between the blade 1 and blade 2, this is the angle. So this is scissor. Okay, so this is real life example for the angle. Always remember, this and this should be straight line only. For example, if I draw a curve like this, see, this is not straight line, this one starting point. From starting point, see, this is not straight line, there is a bend here, correct? There is a bend here, so because of the bend, it is not straight line, it is a curve. Even this, see, bending is there, some kind of bending. Okay, then if this is also curve and this is also a curve, and for this I will not say it is angle. Okay, so remember, this and this should be straight line like this. This should be a straight line, this should be a straight line. Then whatever the space formed between this and this is the angle. Okay, so that you must remember. So this is one real life example for the scissor. Next, see this clip. See, this is this clip. This is like a straight line, this is like a straight line only. So whatever the space forward between this and this, so this is angle. Okay, you can see. So, see, here is an angle formed between this and this, so this is the angle. So cloth clip, this one. Okay, for drying cloths we will use, right, to hold the cloth. So this cloth clip is there, no? This is real life example for the angle formed. Okay. Next, two pens have taken. If you hold these two pens like this, okay, if you keep these two pens like this, so this is like a straight line, this is like another straight line. So whatever the space formed, so this is angle. Okay, so the angle is formed between this and this. Okay. So like this, there are many examples. So book, even book is another example for the angles in real life. See, okay, you hold like this book, you hold the book like this. Okay, see, this is like a straight line and this is like a straight line. So whatever here it is formed, see this space. So this is angle like this. Straight line between those two lines, angle is formed. Okay, see, this is another example for the real life. Not real life, the angles in real life. And you might have seen caterpillar like this. See, caterpillar you have seen, right? Children will use for playing. It is a stick kind of thing. Wood. It's made up of wood. So there is like a thread kind of thing will be there. That will be connected for this and this. And here they will keep stone. They will keep stone and they will drag this thread and uh, they will pull this and just leave that stone will go and hit something. If you want to send stone, small stone for far places, so this is caterpillar. Even farmers will use uh, for protecting their agriculture lands uh, from the birds. They will use this, they will keep stone here, they will drag this thread, so that this stone will go and hit the bird, that bird will go away. So to protect the crops from eating, so farmers also will use this. Okay, so this kind of thing, and it is made up of wood. Okay, see, and here this is real life example for the angle. So here you can see this is like a straight line, this is like a straight line. Between this and this, see, kind of angle is formed. That is the angle. Okay, so angle is formed between this and this. Even here also you can see this is like a straight line, even this is like a straight line. See, here angle is formed, this is angle. Come here, so this is like a straight line, this is like a straight line. So between this and this, a kind of angle is formed. Mhm. There are many examples like this in real life. Okay. Let me give you another real life example. If you take a thread, I will give another example. Ah, another example is nail cutter. So nail cutter will be like this, right? I will just draw a rough diagram. So this is a nail cutter. For cutting the nails, the finger nails, we will use a cutter, right? So in that nail cutter also you can see some kind of angle formed here. This will be like a straight line, even this will be like straight line. So whatever the space formed between this and this is the angle. Yeah, see, there are many real life examples. As of now, I don't have that many objects, real life objects with me. Okay, just understand the concept. Okay, if you understand the concept, what is angle? So you can see many things in real life where angle is formed. Okay, where I will move on to next topic. Next to different examples for the palindrome. Different examples for palindrome. Actually, I have made one short, a small video on this. What is palindrome and all? I've already made a small video like what is palindrome. But in this video, I will give more and more and more examples for the palindrome. Okay. So I've already told in other video what is palindrome like. I will take one example, just a quick introduction. For example, I will take the number 848. Okay. See, if you read from left to right, okay, I mean in this direction, from left to right, if you read the number, how you can read 848? We will read like this: 8, okay, 4. Next, this is also 8. Okay. If you read from left to right, how you will read this? 848. Like this, 848. Okay. For example, if you read from right to left means in this direction. In this direction, from right to left, how you will read? You will read 8. next 4, next 8. See, if you read from left to right, 8 4 8. If you read from right to left, that means in this direction, you will read like this only, 8 4 8. See, this and this are same. So this is also 8 4 8. This is also 8 4 8. So when you read this number 8 4 8 from left to right, it is 8 4 8. If you read from right to left, it is 8 4 8. That means when you read this number from left to right or right to left, we will read the same thing. It is same. See, same thing. So this is called palindrome. So if a number read the same from left to right or right to left, then this number is called the palindrome number. Okay. Now I will give more and more examples for the palindrome numbers. Okay. Sorry, I have just rubbed the term palindrome. So different examples for palindrome. So one example I already gave, that is 848. I will give more and more examples here. See, number 66. Okay. See, if you read in this direction, 6 6. Okay. If you read in this direction, 6 6. Any direction, if you read the same thing, 6 6 6 6. So this is example for a palindrome number. Second one, no, 575. Okay, 575. If you read in this direction, I mean from left to right, 575. If you read in this direction, 575. See, it is reading same thing. 5. If you read like this, 575. If you read in reverse direction, then also 575. So that's why it is palindrome. Next, one more example, 797. If you read in this direction, 797. If you read in this direction, 797. So in both the directions, it is reading the same, 797. So that's why it is a palindrome. Next, another example is this one. So if you read in this direction, how we will read? 1 1 1 1. If you read in this reverse direction, how you will read? 1 1 1 1. Same thing. Any direction if you read, it is the same thing. This number reads same. Okay. So this is palindrome. Seven seven. If you read in this direction, 7 7. If you read in this direction, again 7 7. It reads same in both the directions, so it is palindrome. Palindrome. Next, sixth, 121. See, if you read in this direction, how you will read? 1, 2, 1. Read in this direction, 1, 2, 1. Same thing. When you read in both the direction, the voice or the tone or voice, that is same. Like 1, 2, 1. In other direction, if you read 1, 2, 1. Same thing. The tone is there, no? Tone is same in both the directions. It is same. 1, 2, 1. 1, 2, 1. Like that. The tone voice is same. That means that the number is reading same in both the directions. So that's why it is the palindrome. Okay. Next, seventh. So 363. See, if you read in this direction, how you will read? 363. You read in this direction, how you will read? 363. See, in both the direction, reading is same. Okay, the tone voice is same. So that is palindrome. Next, eighth example. So 484. See, read in this direction. I mean from left to right. It is 484. So read in this direction. That is from right to left. 484. In both the ways, if you read, it is the tone is same. 484. 484. So that's why it is palindrome. Okay. Ninth example. So 313. So this number is, the number is 313 only. Okay. But the point is, you should not see how it reads in both the direction as a number. I mean, you should read the digits. You got it? You have to read the digits, not the number and not the entire number. Okay, remember, digits you have to read. In this direction, if you read, it is 313. In this direction also, if you read the digits, it is 313. So in both the directions, the tone or voice is same. 313. 313. Okay. So that is palindrome. Next, another example. This one. So if you read in this direction, 2, 2, 2. If you read in this direction, 2, 2, 2. See, in both the directions, it is reading the same. Okay. So this is the different examples for the palindrome. Next, we will move on to next topic. Okay. So before moving to next topic, just 2 minutes. Take just 2 minutes break. Till then, just go through this. Okay, for just 2 minutes. Okay, that's all. Yeah, I'm back. I will move on to next topic. Next topic is faces, faces, edges, and vertices. Vertices of of solids. Okay, this is the topic: faces, edges, and vertices of solids. Okay. First, solids. Solid means those are the objects that have three dimensions. So, three dimensions in the sense it has length, width, and height, not just length and width. For example, uh, see this cuboid. This charger in the shape of cuboid. Okay. See, this is length. First, see, this is length. This is length. This is width. This is width. This is height. Okay, so three dimensions. So that is solid. Okay. So first solid I will take cuboid only. Cuboid. So cuboid, how it looks cuboid, I will just draw a rope diagram. So this is cuboid. So it has three dimensions. This is length, this is width, and this is height. So because of three dimensions, it is a solid. Okay, solid. Now the topic we are discussing is faces, edges, and vertices. First, face. So see, this is in the shape of a cuboid. See, first I will take any one example to show you to make understand what is face. So to see, this is one face. Okay. See, this is second face. Okay. This is third face. Okay. And this is fourth face. This is fifth face. And this side, this is sixth space. Okay. Forget about this and this. And even it is, okay, it is not exactly cuboid, but it is looking like cuboid like this. Just a real life example. Okay. So better I will take book only. See, this book also a real life example for the cuboid. Like this is length, and so this is width, and this is height. So face means this is one face, this is second face, this is third face, this is fourth face, so this is fifth face, sixth face. So those are the faces. So like this cuboid has six faces. Okay, how many faces it has? 6 faces. Okay, just now I have shown you what is the meaning of faces and all. So this cuboid has 6 faces. So faces is equal to 6. Next to edges. How many edges it has? Edges. Edges is equal to how many? So edges means, see this one. So this is one edge. This is second edge. Okay. Two edge. So this side. Third edge. Fourth edge. Okay. Fifth edge. Sixth edge. This one. Seventh edge. Eighth edge. Eight edge. Here, one more thing. Here, this one. See here. This is ninth edge. This is 10th edge. So 11th edge. 12th edge. So edge means that. So in the figure, if you want me to show, so edges is equal to 12, right? So this in the real life example, I have shown you what are edges. So on the diagram, same thing. How can I say? So this is one edge. Okay. This is second edge. Okay. This is third edge. This is fourth edge. Fifth edge. Sixth edge. Okay. Seventh edge. Eighth edge. Okay. Ninth edge. 10th edge. 11th edge. 12th edge. You got it right? So edges is equal to 12. Okay. Next vertices. This one. So vertices are corners. Both are same. First, through this real life example, I will show what are vertices. Corner points. In this, see, this is one corner point. This is second corner point. Corner, it's like point. Okay, sharp point. This is 1, 2, 3, 4, 5, 6, 7, 8. So 8 corner points are there. Okay. So 8 corners. So corners is also called as vertices. So vertices is equal to 8. So on the diagram, if you want me to show the vertices, so I will show like this. See, this is one corner point. This is second. This is third point. This is fourth. This is fifth. This is sixth. This is seventh. This is eighth. Okay. So 8 corner points are there. So vertices is equal to 8. Okay. I hope you understood. Next. So cuboid is done now. So next figure is cube. I will take a cube. So diagram I will draw like this. This is cube. So what is difference between cube and cuboid? See, cuboid has different length, widths and heights. But when I say cube, okay, length is equal to width is equal to height. So all side lengths are equal in length. Okay, length, width, heights are same. So that is cube. When length, width, heights are different, then that is cuboid. Okay. Now in this cube, okay. So see cube. Cube also it is looking like a cuboid only. Everything is same. Shape is same. It looks like cuboid only. The only difference is cuboid has different length and width, heights. But cube all length, width and heights are same. Okay. So but your point is whatever the length, width and height, whether same or different. But for cube and cuboid, faces is equal to same 6, edges is equal to same 12, okay, vertices is equal to same 8, okay. So both cube and cuboid have same faces, same edges, same vertices, okay, because these three does not depend on the length and width, okay. It so these three things mainly depend on the shape, how it looks. Since this looks like a cuboid, the only difference is length and width, heights. So, but these won't change. Faces, edges, vertices won't change. So, for cube also same thing. So, next example, I will take a cylinder. So, next cylinder. So, first I will draw the figure of the cylinder. So, cylinder means it looks like this. So, this is cylinder. Okay. For cylinder, faces, edges will change. I will just erase the, sorry, rub the numbers. See, pen is there, no? It actually looks like a cylinder only, okay? This pen is not exactly looking like a cylinder, but it is not exact cylinder, but looks like. It looks like a cylinder, so that I can explain you the faces. See, this one thing starting from here, if you go like this and if you come like this is there, no, this is one face idu, this entire thing, okay, this entire thing is so this entire thing is there, no, this is one face surround, you see this one, this is one face, entire thing, this one. So this is one face. So our the back side also it is there like this. So this is front side. So back side also there, sides also there. So this is face. So this is one face. This one. Okay. This is one face. And here this top one. This is second face. And this one. This is third face. Okay, but on the diagram this is phase 1, this is phase 2, this one, and this is face 3. So how many faces this cylinder has? 3 faces. Next, edges means edge. How many edges? To understand edge, see if you cut this cylinder, if you cut this cylinder with a scissor like this here, like this, if you cut, so cylinder looks like this. When you cut this with a scissor, and if you remove, it looks like a paper, rectangular paper. Okay, when you cut with the scissor. So now this is one edge, this is another edge. So we will consider like that 2 edges. So edges is equal to 2. Next, vertices. Vertices means what? Corner points. So in case of cuboid, see, if I draw like this, see, the sharp points are 2 straight lines are meeting. 2 straight lines meet at a point. Okay. So this is corner or vertex. Okay, vertices means that is a plural form of vertex. Plural form of vertex is vertices. Okay. If more than one, we will say vertices. If there is only one, we will say vertex. So vertices means corners. How many are there? If 2 straight lines meet at a point, this is the vertex. But in case of cylinder, see, of course, so this is looking like a straight line. But actually, see, this is real example for cylinder. It is not a straight line. This is circle kind of thing. See, if you start from here, it will go like this. It will come like this. It's kind of circle. Circle is a curve. It is not straight line. Even this also, say top. This is circle, not straight line. So this is also like a circle only. Okay. If 2 lines meet at a point, that is corner. But here there are no lines or straight lines. Curves are there. So because of that, so there are no vertices. There are no corner points. So vertices of cylinder, we will say no. There are no vertices. Next I will take so this is second example. So not second, it is third example. I forgot to write the number here. This is third one. Next, fourth example. Fourth example is cone. Not example, the fourth solid. The fourth solid or 3-dimensional object we are going to discuss is cone. So how the cone looks like, I will draw the diagrams. See like this. So this is cone. Okay. So real life example for the cone is ice cream will be there, no? Ice cream. So ice cream will be like this. Okay. It will be like this, and here ice cream will be there here on the top. On the top they will keep ice cream, but it looks like a cone. See here. So cone. It looking like a cone. So that is real life example for the ice cream, cone. Just assume it is like a ice cream. Okay. Now faces. First faces, edges and vertices of cone are different. I will just erase the numbers. First faces. See, this is. So I'm just shading the region. So this is one face. This is one face, and this one. So this is second face. Okay. So there are two faces. There are two faces. There are two faces. Okay. Next, edges means how many? So we will not consider this as a edge for cone. Even this is not the edge. So we will consider this entire thing is one edge. This one. Okay. So one edge is equal to 1. Next, vertices means vertices. I told no vertex. So corner point. Two straight lines meet at one point, that is corner. See, it is like a straight line. It is like a straight line. It's looking like a straight line, but actually, if you see that ice cream cone, that is not exactly straight line kind of thing. It looks like a curve shape. Okay, in real life, if you see that ice cream, but your but still there is a corner point exist here. See, if you just assume uh, these are like straight lines, here there is a tip is there, ice cream tip. So that is sharp point is there. So one point is there, sharp point. So we consider this as a vertex for cone. So number of vertices is 1 only. We will write like 1. So this cone is the fourth one. Fourth solid. Next, sphere. Fifth one is sphere. Sphere means it looks like a ball shape. Okay, it is look like a ball. So see, sphere means it is not a circle. You have seen ball, right? Okay, the ball we will use for playing cricket and all, right? The ball. So that ball shaped object is the sphere. See, ball. But if you want circle, bangle, the ladies wear bangle, right? So that is real life example for the circle. But ball is there, no? That is the example for sphere. Sphere is different, circle is different. Okay. So as for sphere, we will see how many faces, edges and vertices. See, this entire thing we will consider as one space only. So not space, face. F-A-C. I'm going to shade the region. This entire thing is considered as one face. So faces is equal to 1. And this ball, if you have seen, So we will, there are no edges here. It is like it's a rolling object. It is a rolling object. It is somewhat looking like a circle. Circle is a curve, right? So so sphere, remember, just remember, don't overthink. Just remember, sphere has no edge. For edges, no, we will say. Usually, when I say edge, there should be a straight line, or if you cut using scissor, we should get the straight line. But here we won't get like that. So, in case of sphere, so practically, if you try to do, you may understand very well. But as of now, don't overthink. Just know edges is equal to no. Next, vertices means corner points, sharp points, corner points will be there. But the sphere, if you look at the ball, there are no such sharp points. It's somewhat a ball kind of thing, curve kind of thing. It's a rolling object. See, if there are corners, for example, if you take a box, okay, mm, tiffin box or whatever, rectangle, if you take any like geometry box, see geometry box, it has corner points. See, if since it has corner points, it cannot move like a ball. See, ball has no corner or sharp points, so it will roll, it will not slide, it will roll. Okay, you know, right, how the ball moves. It has no corner point, that's why it moves like that. If it has corner point, people will not use that for playing cricket and all. Okay, so see, it has no corner points, vertices, that ball. So ball is a sphere, it is an example for the sphere. So vertices, no, we will say no, there are no vertices in sphere. Okay, just 2 minutes break. Just go through this once, just 2 minutes, we will move on to next topic. Next to I will rub this out. So next topic, open figure. Open figure and closed figure. First open figure I will take. See, this is open figure. Okay, open means there will be some opens will be there. It is not closed. I will closed. So this is closed figure. See here, see this side it is completely closed. Here also closed, this side. Even this side also this is completely closed, this side. But on the top here there is a open. So if you want to pour water, you can easily pour inside the water. You can fill the water. You can see on the top there is a open. So we can pour the water and you can keep the water here. But here see, it is example for closed figure. We cannot pour water here. It is completely closed. See, there are no any opens. There are no any opens like this. See, if I remove something here, see here is a open. You can pour water. You can pour water here. See there is a open here. But if it is like this, there is no open. You cannot pour the water. So there are no any opens here like this. So this is completely closed figure. So that's why it is called closed figure. This is open figure. So there is open here. Here there are no opens. So it is closed figure. Okay. So triangle. Triangle also closed figure. There are no opens. This side completely closed. This side also completely closed. So it is example for the closed figure. Okay, if you take a lunch box and if you remove the top plate, so lunch box is like this. Okay, if you remove the top plate and here it is the open, so it is open figure. So even a square say open, sorry, closed figure. Okay. So the simple yeah, that's all. We will see next concepts in other video. Oh, thank you. Okay. And if you like this, subscribe.